Greetings, everyone. My name is Sanjiv, and welcome to another edition of User Delight with Microsoft Technology. In this episode, we'll look at controlling DC motors, both input and output, from the Microsoft Excel data streamer and a tiny little board called ESP32C6. Well, let's head on over to details to know more. Thank you very much.
Right. So let's look at the setup first. What we have is a DC motor here, and the DC motor actually has a built-in encoder at the back that detects the speed. And this is connected to the LN298 motor driver, which is basically an H bridge. And this receives power from a regulated power supply. I've got a battery here, and the battery basically sends approximately 12 volts or so to the input, and then I'm stepping it down to 9 volts, and then feeding it to the 298 motor driver, and from there to the connections to the motor. Now, let me actually walk you through the Excel that runs the code behind this. So if I were to go to Excel here, within Excel, you have what is called as the data streamer. I'll give you in the comments the link to download the data streamer. And then once you download it, you can go to File, you can go to Options, then go to Add-ins here, and then go to COM add-ins, and then click Install Data Streamer. You click this, click OK, and you'll see the data streamer show up. Now, once you have the data streamer, first of all, you will actually need to connect to the device. So what I'm going to do here is I'm going to stop this for a second, and I'm going to stop data, disconnect the device. So if I were to do the drop down to the device here, you will see that I have the little device, the ESP32C6, the board, the Arduino board that provides the input signals to the motor driver, right? So that is connected over USB over a serial port here, and so I'm going to connect it right now. So once I connect it, I get options to start streaming data. So where do I see this? I could either go to Advanced, or I could actually go to Settings and Manifest. If I go to Settings here, this is basically telling me the intervals between data points. So right now I have it at 150 milliseconds. I can go up to 1,000 milliseconds or go down to 10 milliseconds. The number of rows of data, so you can get to about 1,000,000 rows, but then effectively for desktop engineering, I would say for rapid prototyping, I would say anywhere between 250 to 500 is good enough. You can actually get 10 channels worth of data from different sensors into the data streamer, and the orientation here is the latest one being last or first, the latest data point, so you can control these. Then you go to the manifest here and you can set the baud rate. Now, this needs to correspond to the rate at which the data is streamed in from the code that is on the ESP32, right? So they need to be synced. And if you want to, you can also go to the advanced setting here and then look at the same thing, go to settings, the port, the serial port, this is automatically detected. And then you can set the baud rate here as well, right? If you want to, you can set the data bits to what is equivalent on your ESP32. And then you basically have the manifest, but then we don't want to mess with this right now because we've already done it down here, right? So once you do this, you get two tabs, data in. So this is where the data actually comes in from the sensor. In my case, I've actually set it to 250 rows, and this is where you can set it to up to 1,000,000 rows. But then from a practical consideration, I think anything around 500, 250 should be good enough. And you have 10 channels to stream the data in from, and this is automatic, right? Then the data out here basically is the input that you provide to control, in this case, the motor. and it takes command after command, like, separated, comma separated, basically an ASCII character, comma separated, right? And so if you were to provide, let's say, a PWM, a pulse width of, let us say, 500 in a range of 0 to 1024, so that would go into controlling the motor, and then channel 2 in this case goes into controlling the direction, be it 1 being clockwise, 2 being counterclockwise, and so on and so forth. Just depends on how the wiring is set up on the motor, right? Now, if you want to bring everything together, what you could do is, in a summary, you could have a system input for the pulses and the direction, and this basically links to the data out here. And you could have the output as well in one place, so you can actually do the input and then visualize the output, in this case the RPM from the motor, right? So what I'm going to do is I'm going to start the data here. I'm going to basically go with 350 pulses, so that will actually set the motor in action. So if I were to go to the motor, there it is, it's actually rotating, right? So let me put it back to 0. And as you can see here, the data is streaming in right now. If I were to scroll down, it's actually coming up, as you can see, right? The pulses are coming in, and then you can literally see the chart showing you, and this is all Excel. I'm sure you're familiar with, creating charts and so on. So this is a real-time chart, and you can also do, of this data, the speed data that is coming in, you can also do a frequency analysis with an FFT and so on and so forth. That is a separate video in and of itself. So what I'm going to do is I'm going to put it back to 0. I'm going to stop this, and I'm going to stop streaming the data. So now let us continue with this setup. So if I were to go to the video here, basically from the motor, you will see 5 lines. Let me zoom in. You will see 5 lines here. You see the red, so this is basically the input to the motor, and the input to the motor basically could be, anywhere. It just depends on the motor specifications. In this particular case, it goes from effectively about 5 volts to about 12 volts DC. Then you have the ground to the motor. And from there, you have the encoder ground. So this green one here is the ground to the encoder. Then you have the orange one, which provides the power to the encoder. This has to be separate. So the power to the motor, I'm actually providing it from the battery here. But the power to the encoder, I'm actually using the ESP32 out here, right? So this orange corresponds to the 3.3 volts that is being input from the ESP32, and that's good enough to run the encoder. And then you basically finally have the encoder signal. I should have probably used a white data line for this, but this data line controls encoder A, right? And if I were to go back to the web here, this here, and I'll provide a link to the site as well, it provides you what the configuration is. So the red is motor positive, black is motor negative. If you swap it, it basically just swaps the direction of the motor spin, but nonetheless. Then green here is the encoder ground, and then the BCC. These absolutely have to be according to what is called out here. You cannot do bidirectional because the power is coming in to the encoder BCC from the ESP32. And then if you have one encoder A in channel A provides you, the reference to get your speed, right? So this is essentially the setup. Now if I go back to the video, you will see this is a small tiny board, the ESP32 C60M. It is from WaveShare. I'll provide you a link to this. And this basically goes in and gets connected to the serial port. It gets connected to the serial port here. So carrying on, let us look at the connections to, from this board, let us look at the connections to the motor. So to the motor driver. So basically what you have here is essentially the input to the motor. So you have the terminal which gives you the VCC. This basically has to be 12 volts max here. So I'm bringing in the from the DC, I'm going to move this out a little bit if I can. There you go. So from the DC converter, I'm bringing in 9 volts here as an input. There is ground. I'm going to move this motor out if I can. So the ground here is connected to the ground of the negative terminal of the DC, right? Negative, positive, and this is the input. Then you also have to have the ground, common ground, between the ground on the motor driver and the ground on your ESP32, right? So let me try to see if I can flip this. Perhaps I can. I've like stuck it, so let me see if I can turn this over. So basically the green all the way here corresponds to the ground. Not terribly sure if you can see this, but maybe what I could do is I could give you online a description of the pinout. If I could focus in on this. It's a bit poor, kindly bear with me here. Right, so as you can see, there is the ground pin right there, the second pin towards the left, right? So that's the ground pin, and that ground pin gets connected here to the motor driver common ground, okay? So then the output, I'm basically using, this is a bit disorienting, apologize, but then the output from the LN298, the H bridge, I'm using one of them, and this basically the positive and negative. In this case it really doesn't matter. You can flip it and the direction of the motor changes, that's about it. This goes into the positive and negative of the motor right here, the positive and negative, okay? So that kind of sets up the the basic power. Now what you also have to do is to supply PWM, the pulses, to the board. So if I were to zoom in here a little bit, you will actually see 3 pins on this. The enable pin, that sets up the first pulse. You also have correspondingly another one, enable B, that gets you the second PWM, but this is for the second motor, but I'm not using the second motor here. And there you will also see that there is a pin that you need to take out in order for you to use the PWM. The reason for this is if the pin is there, it basically provides a 5 volts directly to the motor, right? But we don't want that. We want it to be pulsed. So what you do is you remove the pin and then you feed the PWM here, the ENA, right? The enable pin. You feed the PWM from your ESP32C6. In my case, this goes to pin number. If I were to hold this properly here, it goes to pin number 4, right? Pin number 4 here is the PWM pin and goes into ENA here, the enable pin. Now in addition, you have 2 other pins. You have IN1 and IN2 that basically control the direction. And these are logic pins. If one is high and the other is low, the motor spins in one direction, and vice versa. If both are actually high, the motor, if both are basically low, the motor just stops, right? So those are just logic gates. and they are connected. So the white and the blue cable here, the IN1 and IN2 are now connected here to pins 2 and 3. So 2 is IN1, 3 is IN2, and pin 4 is essentially the pulse. So that basically completes the setup of the hardware. So what we now do is let us go over to GitHub Copilot, right? So I'm on GitHub Copilot, and on GitHub you actually are able, so I have my repository here in GitHub, and then you can actually use the Copilot on GitHub and do a new chat. And then when you do a new chat, you basically tell it, hey, look, I'm trying to connect my LN298 to the ESP32C6 board and help me with the connections and the code. So it gives you the whole 9 yards. So as you see here, this code is basically run on Arduino, so it's an Arduino library. And then the pin for directions, so in this case it says 5, 6, and 7. But if I were to literally go over to my code on Arduino, it basically is on 2 and 3 as you saw on the board, and 4 is the PWM pin. And then this bit of code here corresponds to the frequency. So a frequency, basically PWM frequency 1000 Hertz. The resolution is 10, so it goes to 1024, 0 to 1024. And then we are curtailing the max duty cycle to 1023. Essentially what this does is that it basically says, hey, look, the max is 1024 minus 1, which is basically 1023. And then you're initializing the direction to 1. 1 corresponds to clockwise and 2 corresponds to counterclockwise. I believe so. I can't remember right now. I need to check the motor. But nonetheless, so we are initializing it to one direction. Then you basically go in and then you look at what applies to the encoder. So the encoder pin is 22. So that's the one that sends the signal from the Excel data streamer over to the ESP32, from there to the encoder on pin 22. And then you have your counts per revolution set as 600, and then initializing the pulse count as 0. This is to actually construct the RPM, right? Now further, you basically go in and then you look at an interval of like 100 milliseconds. This you can set it to 150 if you want, align it to the data streamer, and then you basically have your setup. So in your setup, right, I'm setting the direction here as if it is 2, then set pin 1 to low. If it is 1, set to low. Otherwise, set 2 to high. And then the flip of this would be IN1 as high and IN2 as low. So if the direction, the variable for direction is 2, it basically goes anti-clockwise, and if it's 1, it goes clockwise. I mean, we can see it from the motor. It just also depends on the wiring. If you flip the wiring, the direction changes. Then you've got the actual setup. We are doing the baud rate as 115, 200. What we need to do in our data streamer as well is to set the same thing. If I were to go to the manifest here, I need to set the baud rate here to the same thing. Otherwise, there'll be an issue in bringing the data, right? Then you go in and actually set the pin mode, the 1, 2, and enable pin, basically to output. And then you are using a method called LED attach, right? LED attach, and these two will attach basically the pins, the frequency, the PWM bits, and then which channel. We are on channel 4 here. And you indicate those variables, and then the right channels, this is basically the attached channels, and then the right channels is the PWM and the duty, right? So then you go in basically and you attach the interrupts in order for you to be able to get the RPM information from the encoder, right? And then with a little bit of delay, you print the RPM, and then because we are bringing it into the data streamer, you indicate that the headers are true as well, just the headers, nothing else, no data points, right? And then you finally go loop this, right? So if I were to look at the loop method here, we are checking for the serial being available, and then we basically go look at, the data information is sent line by line, so you're basically looking at the slash n, which is the next line, and then you trim it, so you remove any spaces, and then you're essentially looking for comma as a delimiter, separator, right? And then you separate it between duty and direction depending on the comma index. So the first one at 0 is going to be the duty, the second one plus 1 is going to be the next one, the direction, right? And then any spaces you trim it. And once you trim it, you basically put it inside of variables, right? And this is where you're actually saying, hey, look, if the string length of the duty cycle is equal to 0, then don't do anything. If it is actually greater, then you take the value. If the digits are more, you basically put that inside of a variable. And then you're checking in this bit of if statement, what you're doing is you're checking to see if the value for the duty cycle is greater or less than 1023. If it is greater than 1023, you basically say, hey, use the max. But if it's lesser, you just take the value. And you're checking here, if it's less than 0, it is 0. If accidentally you type -5 in your Excel data streamer, it would basically validate and make it equal to 0. And if you're over 1023, it defaults to 1023, right? And then it basically writes to the channel, right? It also looks at the direction the same way, makes sure it is 1 or 2, and then it sets the direction here, right? Now, then the final bit of code is on the interrupt. Basically, you're using a function called melis, and then you basically check the previous value and the new value, and as the signal actually rises, that is going to be your threshold and for the pulse count to actually start. So initialize the pulse count, and then you start bringing in the value, right? And then you basically convert that to RPM here, by dividing by 1,000 and multiplying by 60 essentially, okay? And then you're finally saying that, hey, the RPM has a count accuracy of 3, and that's about it. That completes it. Now, first things also I should back up a little bit. When you plug in your ESP32C6 the board, what you need to do is to go into tools, and then you go to the board, and then you find the ESP32 library, and from where you select the ESP32C6 dev board, right? So you would have to go to the library and install this. So if I go to the library here, and if I were to search for ESP32 and hit enter, you will actually see a bunch of, and let me see if I can see the C6 here by any chance. Not really. The ESP32 should be good enough. Let me see. Which one? I will have to get back to you on which exact library. That probably it's in the preferences, if I'm not mistaken. Well, I've actually used this one. I'm going to put this out, ESP32 package. So I'll share a link to this one. You go to preferences, add this, and once you add it, you will be able to go find in your board your ESP32 library, and then select the right module, the ESP32C6 module, right? And once you do that, you go to the port, and you will actually see that the board is connected to the port. What I'll also do here is, let me go to Google and search for ESP32C60. This is on Wave Share. There you go. And Uh, Perhaps instead of wiki, we could go directly to the development board here. Probably not. It is from Waveshare. There you go. That's the one I'm looking for. I'll put the link to this as well. So it gives you the configuration of the board, right? What the board actually looks like, board specifications, you know, and then what's on the board, right? Both you know, what kind of a micro, you know, chip it is, right? Then it shows you the USB where you provide power. It also has a board reset as well. You know, the boot and reset buttons, but you don't actually worry about that right now. And then it gives you the pinout definitions, right? So I'm using the PWM pin number 4 for PWM, and I'm sending the toggling the gates to low and high to get the directionality of the motor between 2 and 3. And then essentially 22 is the one I'm actually sending the code for the encoder, right? And you have the ground that is the common ground between the LM298 and the motor. And then you have the 3.3 volt output for the encoder, okay? And that's about it. So once all this is ready and then your code is ready, so you basically go verify the code, make sure everything is okay, especially check for the pins, make sure that the pins are right, your 2, 3, and 4, and 22 out here. Also verify the baud rate, so 4 things to completely verify. And then once you do this, you basically, your verification will go okay, and then you flash this to the actual board. And it will look something like this. If I were to redo this, I think this should be fine. So this is basically compiling the sketch right now, and I'm just going to redo this, right? So it basically will go in and say that, hey, you know, there are no issues here, right? And then you can finally go and upload this. Once everything verifies okay, you can upload this to, I do have to disconnect the device here, right? In your Excel, you need to disconnect the device so the communication is free. So I'm going to cancel this, and then I'm going to actually resend this, re-upload this, okay? So if the data streamer is on, you will not be able to upload it because it's busy, right? So there you go. So this goes ahead, and then finally, you know, hardware setting, everything is good to go. If you want to, you can actually use the serial monitor. As you can see, the, you know, the data points are coming in, the speed data points are actually coming in. If I were to go to the camera really quickly, the motor is also spinning right here, right now. Kindly give me a second. Let me bring up the camera. So as you can see, it has started because I am using 350 pulses to begin with over here, right? So that is that. So I'm going to take off the serial monitor here, and then I'm going to go to Excel, and I'm going to connect the device now, right? So I connect the device once again, and all of these setups have been done. And because this is done, I go in, and then I go to the summary, and I provide a pulse of 0. Oh, well, I need to start the data, and then I need to provide 0, and that's about it. Okay. Let me see if there is anything else here. I don't believe we have anything else. Let me just see. Did I cover off everything? Yes. The wiring, the control and the direction, as well the pinout, and then of course the actual visual. Okay. I trust this gives you a full view of from A to Z how to connect, do the actual hardware connections, B, how to actually load the code from your Arduino to the ESP32C6, and 3, how to connect the ESP32 to Excel and then set up Excel data streamer in order for you to stream the data in from the encoder to the RPM to the Excel, as well as to control the motor from Excel. Okay, thank you very much. Much appreciated, and wishing you the best in your adventure. Thank you so much. Cheers.